Welcome to all. Good evening, all the viewers. Myself, VETRIVEL, Unacademy Plus Educator. Welcome to Unacademy YouTube channel. Champion batch is on progress for complete syllabus coverage. Unacademy is the best and number one online platform coaching in India. So today we are going to discuss the important concept of relative velocity and based on numerical. Right? So once again I welcome all the viewers. Relative velocity in two dimensions. The term relative velocity is used to compare the velocity of two bodies in terms of displacement velocities, right? Relative velocity of one body with respect to another body. Always we will compare. See, for example, relative velocity of one body VA and relative velocity of another body VB. If the two bodies have velocity VA and VB, how can we compare these velocities? The relative velocity of one body with respect to another body is given by general formula. Relative velocity of body A with respect to body B is VA minus VB. If the two bodies moves in the same direction, then what is the relative velocity? If the two bodies moves in opposite direction or moving towards each other or moving away from each other, what is the relative velocities? Right? So we are going to discuss that an important problem. Let us see the first concept. If VA and VB are the velocity of two bodies relative to Earth, then what is the velocity of A relative to B? VAB equal to VA minus VB. This is if the two bodies moves in the same line, same direction with the velocities VA and VB relative to Earth. What is the magnitude of velocity of A relative to B if they move in the same direction? Then this is velocity of A with respect to B, VA minus VB. Suppose the two trains moves in the parallel track, same direction. Then the velocity of one train with respect to other, both are moving parallelly, same velocity, same direction. Then the relative velocity of one with respect to other is difference between the two. Right? Then if they move in opposite direction, if the two bodies are moving towards each other or away from each other, see, moving towards each other or away from each other with the velocity VA and VB, then the magnitude of A relative to B, so will be vector sum of the two, VA plus VB. Previous one, just remind, if the two bodies moving with the velocities VA and VB moving in same direction, then VAB equal to VA minus VB. If the two bodies moving with the velocities in opposite direction or move away from each other, then velocity of first body minus velocity of other body in opposite direction, that is why negative sign. So VA plus VB, it is directed towards A or away from A. So this concept, remember, relative velocity of one body with respect to other body, if they move in the same direction or opposite direction. This is important. Now, different cases in terms of relative velocity. First case, you can see that if the two objects moves with equal velocities. Right? Object A and object B both are moving with equal velocities. That means we know velocity of body A is equal to velocity of body B. Then VA minus VB equal to 0. If the two objects moves with equal velocities, then the two objects stays at constant distance apart during the entire journey. That is why the position time graph shown here. Right? The two bodies moves with the velocity of body first object A, its velocity VA, velocity of second object VB. Both velocities are equal. Both bodies moves with the same velocity. Then they always moves with a constant distance apart. That is why the graph between position time always shows parallel straight line. They maintain a constant distance, right? So this is case 1. If the two objects moves with equal velocities, their position time graph of two objects are parallel straight line. They maintain the same distance. Then if the both object A and B moves along parallel straight line in opposite direction. See, first case moves in the same direction. First case you can see that they move, both bodies A and B moves with the velocities VA and VB, both are equal. Then they maintain the constant distance throughout the journey. The second case, if the object A and B moves along parallel straight line in opposite direction, this only important, they moves in opposite direction, then the relative velocity of body B with respect to A is VB plus VA, sum of. So this concept again very important, keep in mind. So if they moves in the same direction, if they moves in opposite direction. Now let us come to examples of relative motion. Right? First let us see relative velocity of rain. Consider if you are walking towards, suppose the velocity of the man from origin is moving towards east direction, velocity of man. Rain is falling vertically. This is velocity of rain. Right? So, what is the relative velocity of man with respect to rain? Or what angle he has to hold the umbrella in order to protect him from the rain. So that's the relative velocity of rain, right? So keep in mind, consider a man is walking with the velocity Vm towards, right, represented by OA. That's only the meaning. This is O, it is A, velocity of man. Rain is falling vertically. So from O, the velocity of rain fall vertically, I can take it as OB. Now, what is the relative velocity of rain with respect to man? VRM. Right? So in order to do that, bring this man rest, OA. That means OA vector equal magnitude we can draw in opposite negative vector, you can take it, the same OA dash. This is now velocity of man. That's only is given. To find the relative velocity of rain with respect to man, bring the man at rest. Right? OA you can draw negative vector opposite direction by embossing. That's only, this is now minus Vm. Now see that velocity of rain OB, velocity of man here, this direction. Now the relative velocity will be, this is the relative velocity of rain with respect to man. Right? So now the relative velocity of rain with respect to man, if I take this, the right angle triangle, this angle theta, now the relative velocity of rain with respect to man will be, right, see here, OA represent velocity of man, right? This is OB represent velocity of rain. It is falling vertically, right? 90 degree. Now, in order to find the relative velocity of man with respect to rain, I am drawing an opposite negative vector, right? OA equal magnitude, I can draw an opposite direction. So that is why it's minus Vm. Now easy to solve. Now the resultant velocity, right, is drawn OC. Is a resultant velocity. It's making an angle theta with the vertical. Now, what is the resultant velocity? This make it as a triangle now. Resultant velocity will be now, apply Pythagoras theorem. Right? VR square plus this is Vm square plus 2 VR Vm cos theta. Right? F1 square plus F2 square plus 2 F1 F2 cos theta. Same method solve. So here cos theta is 90. Cos 90 1. Cos 90 we know 0. So completely this term will be neglect. You will get only this. So directly you take it, this right angle triangle, velocity of rain with respect to man is Pythagoras theorem apply. So root VR square plus Vm square. If theta is the angle, then tan theta equal to opposite side. Opposite side, this is Vm. This is Vm opposite side. Opposite side by adjacent. So Vm by Vr. From this, theta equal to tan inverse of velocity of man by velocity of rain. Theta is what angle he has to hold his umbrella in order to protect him from the rain. That's the meaning, right? Here angle theta is formed vertical towards west and it's written as a theta west to vertical because a man is walking towards east. So how can you, what angle you have to hold the umbrella? That's only mentioned here, theta. Right? West of vertical in order to protect him from the rain. This is the concept of velocity of rain, relative velocity of rain. If the man walks towards east with the velocity, right? Velocity of rain is falling vertically, perpendicularly down, velocity of rain. So resultant velocity, for that we need to draw the negative vector of OA opposite direction. Then resultant velocity will be resultant velocity of man with respect to rain is, this is resultant velocity of rain with respect to man is this triangle. VR square plus Vm square. At what angle he has to hold his umbrella? Theta equal to tan inverse of velocity of man by velocity of rain. Now, crossing the river, right? To cross the river in shortest form, see, this is the bank of the river, right? The distance between the banks is D. Now, from O, crossing the river in shortest distance mean, see, he has to cross shortest distance, OB, right? But the man or the boat, we can, if you want to come shortest distance, he has to row the boat or he has to swim in upstream so that the flow of water, see, this is the direction of river. So when you swim against this, in upstream, it will push you automatically, will bring you here. So that shortest distance. To cross the river straight, the man should swim upstream. This is the direction of flow of river. So the man should swim upstream, making an angle theta with OB. Right? Such that the OB gives the direction of resultant velocity. See that AB is given clearly, this is the direction of velocity of river, right? OA, this is the velocity of man. The man is swimming in upstream. This is the velocity of man. And OB is the velocity of man with respect to river, right? So this right angle triangle, now apply the Pythagoras theorem. We know that velocity of man with respect to rain is root Vm square minus Vr square. If we take sin theta, opposite side by hypotenuse, Vr by Vm. If we take tan theta, right, opposite side by base, adjacent, VR by VMR, right? VMR, that's it. So VMR already we know, substitute here. So this is crossing the river in shortest distance. Let us see now how to cross the river in shortest time, right? Time taken to cross the river. See that if D is the width of the river, already I showed you the width of the river is D. Now time taken to cross, we know that velocity equal distance or displacement by time. From the time equal width of the river by velocity. We know that. Now to cross the river in possible shortest time. How to cross the river in shortest time? See that this is the direction of flow of river. The man should go along OA to cross the shortest time. But when you try to move cross, the flow of water will push him automatically will go downstream up to B. So a swimmer will be going along OB. Right? This is the direction of river of water. So which is the resultant velocity of VM, velocity of man OA. AB is velocity of river, right? And we know that now in triangle OAB, take it now, tan theta equal opposite side, right? AB by adjacent OA, we know both. Now what is the resultant velocity? Velocity of man with respect to river, this right angle triangle, take it. Then Pythagoras theorem, this hypotenuse equal sum of these two, you will get. Now time of crossing the river, we know velocity equal, right, distance, displacement by time. From that T equal, we know, right, what is D here? We know width of the river by velocity of man, that is width of the river by velocity. So here when he start to swim straight, the water will push him, he will reach up to B. So what is given? See, the distance is OB, right? Here the OB is drift from A to B. He pushes him, the distance is X. The width of the river is D. So OB is D plus X. Root is given. See, OB, this right angle triangle, OB equals square root of D square plus X square. Right, down we know that already, this substitute. So this have an idea, shortest time how to cross the river. Let us move to the problem number 1. First sum. Based on this relative velocity concept, two parallel rail tracks ran north to south. Try to understand, right? North to south. Two parallel rail track run north to south. Train A moves with the speed 54 km per hour, right? So velocity of train A 54 km per hour, convert into meter per second, 5 by 18, you will get 15 meter per second. Similarly, velocity of B train is 90 km per hour, convert into meter per second into 5 by 18. You will get 25 meter per second. Now we know both in meter per second. The relative velocity of B with respect to A. See that two parallel track, right? Train A moves towards north. Right, towards north it is moving. But train B moves towards south. So VB, it moves towards south. Both are moving in opposite direction. Then we know relative velocity of B with respect to A. Relative velocity of B with respect to A is VB plus VA. Both moving in opposite direction. We know, right? 15 plus 25. 40 meter per second. Right? Or this only correct answer. Negative you can neglect it. Why negative means? Since it's moving in opposite direction. Or you can say relative velocity of B with respect to A is VB minus of minus VA. That's only is given. VB minus VA. VB is A is north direction, B is moving towards south direction. So VB will be minus 25, right? Minus VA is 15. So both minus 40 meter per second. So first option is the correct one. So champion batch is already on progress in Unacademy. So you can use my code VETRIVELLIVE to subscribe Unacademy Plus course, and you will see that complete difference and complete syllabus coverage, right? Everything will be, at least have a try for 1 month trial plan, right? Use my code VETRIVELLIVE to subscribe Unacademy. Now next one. See that the train is moving slowly on a straight track with a constant speed. The passenger in the train start walking at the steady speed of 2 meters per second in the back of the train opposite direction. See, train is moving particular direction, the passenger inside is walking opposite direction, right? So what is the relative velocity of passenger with respect to train? See, train moving particular direction and passenger inside walking opposite direction. So the relative velocity of passenger, with respect to train. We know that both are moving in opposite direction, right? So velocity of passenger minus velocity of train. What is the velocity of passenger moving 2 meters per second minus velocity of train with the constant 2? So 0. So the relative velocity of passenger with respect to observer is 0. So since train is moving particular direction and passenger walking in opposite direction of motion of the train, the observer standing on the platform, right? The velocity of the passengers appears to be 0. For him, it appears to be no movement, nothing. So the relative velocity of passenger with respect to train is 0. So correct option is D. A boat is sent across the river with the velocity 8 km per hour. So what is the velocity of the boat? Right? Velocity of the boat, you can see, this is the river, the width of the river D, right? It is AB. Remember, AB is the now velocity of boat. It is given velocity of boat is 8 km per hour, right? Now BC, this is C now. BC is velocity of river, right? Now this is the resultant velocity, right? Now what is given here? AC, resultant velocity of boat. Resultant velocity of boat is given 10. So the resultant velocity of boat is given 10 km per hour. Then what is the velocity of river is the question. Velocity of river is the question. See the diagram now, right? This is velocity of boat. This is velocity of river. This is resultant velocity of boat with respect to river, right? Now it's a right angle triangle. We know, use the Pythagoras theorem. We can apply. Now velocity of river, right, equal square root of, right, AC square minus AB square. That's it. So AC square what? It is given, right, 10 square minus 8 square. That's it. Root 100 minus 64 root 36. That is 6 km per hour. So the correct option is 6 km per hour. At a metro station, right, a girl walks up a stationary escalator in time t1. she remains stationary on the escalator, then the escalator take her up in time t2. The time taken by her to walk up on the moving escalator will be, right? So keep in mind, metro station, girl walks up on a stationary escalator, right? Then what is the velocity of the girl? Velocity of the girl equal distance, say L, length travel, distance by time is t1. Okay. If she remains stationary on the escalator, then the escalator take her up in time t2. Then what is the velocity of the escalator? The velocity of the escalator equal, that is VE, velocity of the escalator, distance travelled by time t2. Okay. Now, see, first the girl walks up on the stationary escalator in time t1. So, velocity of the girl, distance by time. Now, right, the escalator take her up in time t2. Then what is the velocity of escalator? This is. Now, what is the total velocity of the girl on escalator? Total mean effective. Now, what is the total velocity of the girl on the escalator? Total velocity equal velocity of the girl plus velocity of the escalator, right? L by T1 plus L by T2, right? If T is the time taken, see here, the time taken by her to walk up on the moving escalator, right? If T is the time taken, you assume, right? If T is the time taken, then L by T equal L by T1 plus L by T2. Question is, the time taken by her to walk up on the moving escalator. First escalator is stationary, she is walking. So first one, velocity of the girl. Next escalator take her up. So velocity of the escalator. Total velocity will be sum of these two. Now if the T is the time taken, right? How much time taken by her to walk up on the moving escalator? So now total velocity L by T. T is the time taken now, equal L by T1, add these both. That's it. L common both side. Cancel it. L common both side. Now you will get 1 by T equal to 1 by T1 plus 1 by T2. Take LCM, cross multiply. You will get T equal T1 T2 by T1 plus T2. So option O, right? Now 120 meter long train is moving in a direction with the speed 20 meter per second. A train B moving with the speed 30 meter per second in the opposite direction. So their length is 130 meter. Now what is the total distance then? Right? Total distance is 130 plus 120, right? Train A and B, total distance now. So 250 meter. This is the total distance. See, 120 meter long train. This is 130 meter long. So total distance you got it. What is the relative velocity? Since both trains are moving in the opposite direction, right? Train A and train B moves in opposite direction. Then the relative velocity equal, right, vector sum of these two velocities. Velocity of A minus my opposite direction, that is why minus 20. Or directly we can go 30 plus 20. How much? 50 meter per second. What is the question? Right? So in time, how much time taken? We know total distance, we know velocity. Then what is the time taken? We know time taken equal distance travelled by velocity. Distance travelled 250 by velocity 50. So 5 seconds. Right? So none of this. Right? So none of this is the correct option. Now, a 210 meter long train, right, moving due north at the speed of 25 meter per second. Right? See that a bird is flying due south with a little above the train with the speed of 5 meter per second. What is the time taken by the bird to cross the train? Relative velocity. See here, length of the train moving to north with the speed. A small bird is flying in opposite direction, south. Then what is the relative velocity? Right? The relative velocity of bird with respect to train. Right? Relative velocity. Since relative velocity will be VA plus VB, right? So velocity of train plus velocity of bird. So 30 meter per second relative velocity. Time taken by the bird to cross the train. Time taken will equal distance by velocity. Distance is 210. What is the relative velocity? 30. So 7 seconds it will take to cross the train. Right, next one. See that this already over. Same model we did. Now, the distance between two particles moving towards each other. See that distance between the two particles moving towards each other is decreasing at the rate. Now, both particle moves in opposite direction. Then it will be difference between the two. V1 minus V2 equal to 4. According to problem C, both moving towards each other mean relative velocity will be vector sum. Both moving opposite direction, difference between the two. Solve these two. If we solve these two, we will get V1 as 5 meter per second. V2 will be 1 meter per second. So first option will be correct. Right? And then come to the next one. Two car A and B moving with the same speed, 45 km per hour along the same direction. Third car C coming in opposite direction with the speed. Right? When the two car will meet at the interval 5 minutes, the distance between car A and B should be, right? The distance between the car A and B should be, right, see that here distance between the car A and B is remain constant. See here, moving with the same speed along the same direction. So the distance between car A and B remain constant. Let the distance be x. Right? Now car C is coming in opposite direction. Then what is the velocity of car C with respect to car A and B? Right, what is the relative velocity? Since car AB has constant distance same, that distance we don't know, that is x. Now C is coming in opposite direction. Now once it come opposite direction, what is the relative velocity? Right, velocity of AB car plus velocity of car C36, total 81 km per hour. Now what is the distance? Distance 81 km per hour. Right, here in 5 minutes is given. So 5 minutes convert into, okay, by 16 minutes, hour converting by 60, you will get 6.75, right, kilometer. So first option is the correct. Since C is coming opposite direction, that's all. So relative velocity will be vector sum. That's it. Now come to the last one. A man can swim with the speed 4 km per hour in still water. How long he take to cross the river 1 km width if the river flows steadily? Right? So clearly is given, velocity of river is given, VR 3 km per hour. Right? The width of the river is given, BD 1 km width of the river. Right? So question, try to understand. This is the width of the river is given, right, 1 km. Here this is originally velocity of the man. He has to swim, right? So this is C, river velocity VR. Right, this is the resultant velocity now. The speed of the river is given and width of the river is given. Now what is the time taken to cross the river? Distance by speed. distance is 1 kilometer, right? By speed is 4 kilometer per hour is given, right? That is equal to 1 by 4 hour. 1 by 4th hour convert into minute into 60. So you will get 15 minutes to take time taken by the swimmer to cross the river. Now what is the distance travelled along the river? Distance travelled, time we know, distance travelled equal velocity of the river into time, that's it. Velocity of the river is given 3 into time is 1/4, that's it. So 3/4 kilometer. So this convert into 3 kilometer will be 3000 meter, right? 1 kilometer equal 1000 meter by 4 you will get 750 meter. How far down the river does he goes, right? This we got it as 750 meter is the right answer, right? So that's the end of today's session. I hope you learned, right, the basic of relative velocity concept, velocity of rain and a river boat problem we discussed. We will meet you in another YouTube class next, right? Till then, myself VETRIVEL, Unacademy Plus Educator, signing off from you all. Have a nice day.